Okay, so today we are going to see the Indian electricity grid code. So previous in previous slides we saw the role of NTPC and role of NHPC, right? So National Hydroelectric Power Corporation and National Thermal Power Corporation Limited. So these two institutes are generally develop the particular project. It may be a thermal project, it may be a hydroelectric project, or any renewable project. And it will start from the planning. Okay, planning, selection of the site, and all those will be carried out this particular entities, and finally they will install the or construct that particular thermal power plant or the hydroelectric power plant, and after that also maintenance and the general operation will be carried out by these institutions. Now, the generated power will be given or directly connected, or we can say the directly sale to the state or the center to the electric grid. Now, first of all, you must know what is meant by electricity grid. Okay, then you will understand what is the need of Indian electricity grid code and what is the idea behind this particular grid code. So first of all, electric grid means what? Generally, we know the electricity or the power will be generated in the power station, right? Now, this generated power, it must be passed or it will be uh, given to the consumer. Okay, so from the generation side to transform this particular power or they carry out this particular power from generating station to the consumer, whatever the grid is available or whatever the transmission lines, distribution lines are available, these all combinedly is known as the electric grid. Okay, so electric grid, what it does is it uh, transfer the power from generating station to the final consumer. Okay, so that is mean by electric grids. Now, electric grids will have different or the many components will be there. Okay, there may be a transformers, there may be high voltage transmission line, then substations will be there, transmission customer care will be there, or service station will be there. Then after substation, the voltage will be stepped down. Okay, after step down the voltage, that current or whatever the power will be distributed, or we can say distributed along the different consumers, right, or the customers. Each customer having different requirement, okay, based upon the voltage capacity. So based upon that, this particular power will be transformed or the distributed throughout this particular customer. Now, whatever the all these particular transmission lines, transformers, and other equipments are came under the electric grid. Now, the India have a national electric grid under which it is again subdivided into the regional electric grids. Okay, and again in this particular what you can say the regional electricity grid, again it will be subdivided into the state electricity grids. Now, these grids are just interconnected to each other. Those are all are interconnected with each other. Okay, so this region, we can see there are generally five regions. First one is the north region, eastern region, western region, south region, and the northeastern region. Okay, so as you can see, the different state will be classified into this particular region or the divided into this particular region, and the whatever the power plant came under this particular region will be connected to this regional electricity grid. Okay, those are actually called as the electric grids or the electricity grid, or we can say the power grid. Sometimes it is also called as the power grid. Now, whatever the different hydroelectric power plant and the thermoelectric power plant, different renewable power plant, all power plants will be connected to this particular grid. Okay, and the whatever the power will be generated is given to that particular grid, and it has been distributed among the different customers. Now, generally, what will happen? The power station will be located far away from this particular consumption area or that particular customer. In the case of hydroelectric power plant, those are generally in the mountain regions, right? In the Jammu Kashmir, UT, as well as the Himachal Pradesh, Uttarakhand. It is near to the uh, Himalayan ranges. Okay, so it is away from the main particular customer or the consumer of the electricity. Okay, now to transfer this particular power from this hydroelectric power plant to the consumer required the electricity grid. Okay, now these are the regions as we already discussed. These are the northern region, western region, etc. Now this region again classified, or we can say the divided into the state-wise electric grid. So whenever we considering the western region or grid, it is again classified or the divided into the state-wise or the state grid, state electrical grid. So Maharashtra will having different electricity grid, Gujarat will having different electricity grid, Madhya Pradesh will having different electricity grid, etc. So and those electricity grids are interconnected. Okay, these state grids are again interconnected. Now whatever the power plant available in the Maharashtra, it has been directly connected to the state grids. Okay, now whenever we connect that power that power plant to the electricity grid, any state electricity grid or national electricity grid, we have to carry out some step up or step down activities. Okay, we cannot directly connect that power cable to the electricity grid. There are some instruments are there. Okay. Similarly, when two state electricity grids are connected to each other, there are some procedures or there are some protocol is there whenever we connect the state grid. Similarly, when we connect two different regional grids, regional electricity grids, again we have some protocol or the standard procedure through which we can connect that particular grid. If it doesn't follow the standard procedure, the grid may be failed. That is recently happened in Pakistan, right? So you heard the news regarding the grid failure in the Pakistan. Similar has been happened in India in 2012. Okay, when this particular regional or the national grid has been down for 1 or 2 hours. Okay, so whenever we connecting that particular one grid to the another grid or even the power plant to that particular state grid, we have to follow some procedure. There is some standard procedure or standard protocol is there, standard devices we have to use. Whatever the transmission lines are there, we have to use standard dimensions and the standard material for those whenever we manufacture that particular transmission line. Okay, so all these procedures which is related to the electricity grid, it has been mentioned in the electric grid code. Okay, so this Indian electricity grid code, it has been mentioned here. Also, you can see this is another representation of the different parts of the that particular electric system or the electric grid. This one is the this part you can see. This one is the generation side. Then this power has been transmitted from the power plant to the final consumer. Okay, so it will be transmitted, and this you can see the transmission grid. Okay, in transmission grid, the voltage is very high. It is nearly 110 kilowatt or the 330 kilowatt kilovolt. Sorry, kilovolt means 33,000 kilovolt or 110,000 kilovolt. That much of the uh, voltage is present in the transmission line to reduce the transmission losses. Okay, because when we transmit the electricity having very low voltage, then the losses is also increasing, and because of that, the efficiency, transmission efficiency will be decreases. To avoid that, we just step up this particular voltage after it is coming from the power plant and then transmit it. After transmission, whenever we distribute this particular power among the different consumers, in that case we have to reduce the voltage of that particular power. Okay, so from this 110 kilovolt, we can reduce this into the 50 kilovolts or the required uh, voltage in the houses, that is 420 volt, etc. Okay, it is again based upon the different different practicals or the applications, and this is known as the distribution grid. When we combine this, all grids combinedly known as the electricity grid. And we also saw the different electricity grid. We can again classify based upon the location, regional grids, national grids, state grids. Also, there is a one idea is that the international grid, regarding the international electricity grid. That idea is whenever we this particular we India particularly connect our national grid to the other countries or the other nation national grid, and we can transport the electricity. Okay, so surplus electricity we can provide it to the other nation. So that will be the national international electric grid or the international power grid. So that much that's how we can classify this grid. Now the electricity grid code, whatever the Indian electricity grid code, it is define the parameters of facility connected to the public electric grid. Whatever the power plant is there, when we connect the power plant to the electricity grid, what is the technical specifications are there, or what is the procedure is there, all those has been in, given in the Indian electricity grid code. Particularly, the it is required to ensure the safety, security, and economic proper functioning of the electric system. Okay, because you saw there are many numbers of or the different types of instruments or the devices has been used in the electric grid, right? Transformers are there, transmission lines are there. Then again, there is a substation. In substation, there are different types of the components. There number of components we are using. Now, whenever we connect or the manufacture or construct that particular electric grid, we cannot use any type of component or any type of devices in this particular grid. Okay, we have to follow some procedure, we have to follow some standards, and those all standards has been mentioned in the Indian electricity grid code. Now the grid code will be regulated and made by the central commission. Okay, and the main objective of the this Indian electricity grid code is to lay down the rules, guidelines, standards to be followed by the various persons and participants in the system to plan, develop, maintain, and operate the power system in the most secure, reliable, and economic and efficient manner, while facilitate healthy competition in the generation of and supply of the electricity. So all those rules, procedures, standard dimensions of the standard devices, it has been mentioned inside the Indian electricity grid code. Now, what is the importance of this IEGC regarding the power plants? Okay, it is most important because whenever we generate the power, we have to you, transport that power from the power plant to the customer. So whenever we transfer that, we require some electricity grid. Okay, so whenever we manufacture or we can say the constructed any particular power plant, we have to consider this electricity grid also. Okay, how much power will be transferred? In the case of hydroelectric power plants, those hydroelectric power plants are near to the hilly area, right? So from hilly area to the customer, we have to transport the electricity. So in that case, we must know, or we should know what is the Indian electricity grid code and how to develop that particular electricity grid, which is connect the power plant to the national grid. Okay, so you can also see this IEGC review report. Okay, just I will show you. You can also find this particular PDF in, sorry, one. Okay, just I will show you this particular PDF so you can understand what is the electricity grid code. So this is the draft of Indian electricity grid code, which is to be ineffective from the 1st April 2010. You can see the different introduction, objective, scope of this particular grid code. These are the terms which are used in this report. You can see the introduction part of this particular uh, PDF. Okay, so the Indian Power Station, which is having numbers of agencies, which has been uh, maintained by the different types of the agencies. Now, whenever they will construct this particular power plant and generate power, and that power plant will be connected to the main national electricity grid. Okay, so whenever we connect that one, we require different types of the supplies, or the different types of the devices are required. These are the devices, and whenever we uh, design that particular devices, or whenever we construct those particular uh, facilities, we have to follow some rules and the guidance. So those all guidance will be given in the IEGC. These are the objectives. You can also see the objectives. Okay, scope of this particular Indian electricity grid code. Okay, these are the scope and structure of the Indian electricity grid code. So in the first chapter, general information has been given, like the objective, scope, etc. In the chapter number 2, it is role of various organizations and their linkage with the other organization. It has been also explained. Okay, so in this particular chapter, you will see the role of NHPC, role of NTPC, and their interconnection. Okay, third chapter, that is planning code for the interstate transmission lines. Okay, or the transmission. Then the connection codes are there, operating codes are there. Okay, so these are all mentioned inside this particular codes. Sixth one is the scheduling and dispatch code is there. So all this has been mentioned, clearly mentioned inside the IEGC. Okay, so that is the Indian electricity grid code. You will just read out this particular introduction, or the first chapter of this particular PDF. Okay. The next point, we have to going for the different types of the power plant. Now we have to study the different types of the power plant. What are the advantages and disadvantages of the power plant? What are the limitations and other problem arises whenever we construct this particular power plant? So first power plant we are going to see, it is hydroelectric power plant. So this is the general arrangement or schematic of the hydroelectric power plant. You can see there are different components are there. This one is the reservoir is there, then dam is there. Water will be flown through this penstoke. Okay, there is some pressurized tunnel or research tank has been installed on the penstoke. Then inlet wall is there, and then finally hydraulic turbine. This water will be strike on the hydraulic turbine and it will generate the power. Okay, there is a draft tube again installed whenever that turbine is the reaction turbine. So these are the main components. You already studied these components. Okay, so this is the general arrangement of the hydroelectric power plant, in which we are convert this potential energy of the water into the electric energy, right? So conversion will happen from potential energy to the, sorry, you can see potential energy to the kinetic energy first of all. This kinetic energy again converted into the mechanical energy in the turbine, and this turbine will be connected to the or coupled to the electric generator, which will convert this mechanical energy into electrical energy, and then this electrical power or energy it has been transferred. Okay, so this is the layout of hydroelectric power plant. You already know the working of the different components, right? Now, classification of the hydroelectric power plant. We can classify the different hydroelectric power plant based upon its head, based upon the nature of the load. Now, you already know based upon the head or according to the head, we can classify it in low head power plant, medium head power plant, and high head power plant. Okay, low head power plant means whenever the head available at that particular site or the on that particular turbine is less than 30 meters. Okay, that is known as the low head power plant. Medium head power plants will having 30 to 100-meter head, and high head power plant whenever the head available is greater than the 100 meter. Okay, generally we are using Pelton wheel turbine in this particular case. In the high head power plant, in medium head power plant we are using Francis, and low head power plant we mostly go for the Kaplan turbine. Okay, now according to the nature of load, these power plants will be again classified into two types. That is the base load and peak load. Now, what is meant by base load and what is meant by peak load? This one is important. Now, consider there is one city or consumer is there, okay, and it will consume the electricity with respect to time, okay. It may be in the days or months, we can say, okay. Now, there is a consumer which will consume the energy, and when we plot consumption of electricity with respect to day or month or with respect to time, we will get this like this path or like this curve, okay. Now we know at that particular month or on that particular day, this particular day, this consumer required maximum energy, okay, and all year around it will require mm, less energy than the maximum load. Okay, so if we see this one is the average energy or the average electricity or average load on this particular required by the consumer. Now, whenever we design any particular power plant, we first we have to decide that is that going to provide a base load or the peak load. Now, base load means what? This particular load. Okay, this one. This is the load is known as the base load. Means what? This load or this base load means what? It is the load which is constantly will be there throughout the air, throughout the year. Means what? The customer required minimum that much of energy, okay, or that much of electricity throughout the year. That means to the whole year that base load must be provided or the power plant must generate the base load minimum this much of load, okay. And peak load means what? For this particular time only, it may be 1 month or 2 months, this particular customer required the higher load or they required the more energy or more electricity than the base electricity. Means what? During this particular time period, we have to develop more energy or more electricity, or we have to provide more electricity. Now for that, if you want to construct any particular power plant, we are going to design that power plant based upon the base load. Why? When if we design this power plant which is based upon the or peak load, in that case, for only for this particular instance or time, we are using 100% utilize 100% power plant. Okay, and other for other timing, we are not utilizing the 100%. So in that case, the overall efficiency or we can say the maintenance of that power plant is much more than the in instance. So for this, whenever the extra load is required, in that case also for only for that period also we are switch on the peak load power plant, okay, and we will provide the extra energy. Now there are these all power plants like the thermal power plant, hydroelectric power plant. It has been again classified based upon the base load power plant and peak load power plant. Generally, the hydroelectric power plant or the thermal power plant, nuclear power plant, those are the base load power plant. Now, why this is base load power plant? Because starting on starting of these power plants, generally the thermal power plant and nuclear power plant, it will take more time. Also, the capital investment in those type of the power plants is very high. Okay, so in that case, we are not going to use the uh, the the hydroelectric power plant as a peak load power plant. Okay, in the case of peak load power plant, we are mostly use small hydroelectric power plant, or we can use the diesel engine, IC engine power plants, and the gas turbine power plants, which we can start and switch on and switch off in very less time. Okay, so based upon this also, there is a we can classify this hydroelectric power plant. Generally, large hydroelectric power plant will be classified as the baseload power plant, and the small or micro hydraulic power plants will be classified as the peak load power plant. The next classification will be according to quantity of water available. Now, generally, you saw the large type of the hydroelectric power plants, right? So, in that case, there is a dam and it will store the very large amount of water during the monsoon, and that water has been used throughout the year. Okay, now that is known as the storage type of hydroelectric power plant. Now there are different types of the hydroelectric power plant are available when there is a low head is available. Okay, like the runoff river plant without pondage means what if there is a river, okay, we just construct a dam, okay, and we store very small amount of water there, okay, the head available here is very small, and we just install the turbine that is known as the runoff river plant without with pondage, okay, and if we are not going to store this water, just we are using the flowing water, in that case it is known as the runoff river plant without pondage. Okay, storage type means our general power hydroelectric power plant is there. Now next one is the pump storage. Pump storage we are going to discuss in very details in the next some points. Okay, next one is the mini or micro power plant where the head available is very less, or it is less than the 5 meter, or in between 5 to 20 meters. In that case, those are known as the mini and micro type of hydroelectric power plants. Okay, so these are the classification of hydroelectric power plants. Okay, now India's power scenario is that the this is the data from the December 2022. Okay, the total installed capacity in India, it is nearly 4 lakh 10,000 340 megawatts. Okay, from that nearly 10%, 10 to 11% share is of hydraulic power plant or the hydraulic energy. 10 to 11%. Okay, so and the generally coal will having nearly 60%, 50 to 55%. uh, Renewable energy resources, these are the renewable energy resources, it will nearly 30% will be share of that particular renewable energy sources. Gas turbine or the gas based power plants, that is also having some share, and also the nuclear power plants. Okay, so these are the different energy scenario of the India. You can see the hydroelectric power plant will constitute 10 to 11% of the power generation or the power installed capacity. Okay. Now you can also see generation in November 2022. Okay. Nearly 9.88 billion units of electricity has been generated through the hydroelectric power plant. That's why we are going to study deep study of the hydroelectric power plant. These are the different hydroelectric power plants during with respect to the different 5-year plans. Okay, you can see there are numbers of plans are there and the year. Okay, you can see the capacity, hydraulic energy installed capacity with respect to plan. You can see the share of this hydroelectric power plant will be increases from the independence up to the 80s. Okay, and after that it will be decreases because other type of other type of power plants will be installed. Now the issues which are coming whenever we develop any particular hydroelectric power plant, the these are the important because whenever we going to construct any hydroelectric power plant, we have to consider those points. Okay, because these issues are going to be going to affect the construction of the hydroelectric power plant. Also, it is going to be there are some effects, social and economical effects uh, on the community. So, first issue, that is the difficult or inaccessible locations. Generally, you know, the hydroelectric power plants, you require the hilly area, right? To having that potential water availability as well as the potential, we require the hilly area. So that location is itself a difficult to access. Okay, sometimes we cannot easily access that particular location. So that is the first issue. Second, land acquisition problem. Now that is another major problems is there because for the hydroelectric power plant we require very large amount of area, a large area of the land. So in that case, to acquire that particular land, that is a problem itself. Okay. Then resettlement and rehabilitation issues. So whenever we acquire this land, there are some peoples or villages which has been just we have to relocate those villages. So in that case, a resettlement and the rehabilitation of these particular villagers and the peoples are very important, and that may be a political or social economical issue. Then law and order situation, in the case of generally that has been happen in the case of resettlement and rehabilitation issues. Then geological surprises means what, there are some geological conditions are there or the factors are there which uh, eh, spontaneously came across whenever we start to construct this particular hydroelectric power plant. Then interstate disputes, these disputes will consider the or the constitute the land dispute or maybe a water share dispute. Okay, so these are the disputes are there. Then issues on appointment of project, proportional of the projects among the various beneficiaries. Okay, the capital cost of the hydroelectric power plant is very high. So in that case, one single company, if you single company cannot invest all that mm, cost or all that investment in the construction of the hydroelectric power plant. So in that case, two or three companies are came together and they will construct the particular power plant. So in that case, the proportional costing, project costs, which are divided amongst various beneficiaries, that is also issue. Then process for the or the effects on the environment, forest and wildlife, that is also important. And the excessive burden on net present value. Okay, as we know, the construction cost is very high. The capital cost of hydroelectric power plant is very high. It will take many years to construct the one particular hydroelectric power plant. So in that case, the maintenance cost and all the other cost is very high. So that is again going to be burden on the account. Okay. So these are the issues which are very important whenever we construct any particular hydroelectric power plant. We have to consider these factors, and after that we have to carry out or the start to construct the power plant. Okay. So that's it. We will stop here. In the next lecture, we are going to see some limitation and geotechnical issues, major dams in the India, and site selection. Okay. So similar to this one, we are going to see the different types of the power plant like thermal power plant and other type of power plant, and we are going to take some review of that particular power plant. Okay. So we will stop here. If anybody having any issue or the doubt, you can ask now.